is ready to go now, I believe. Welcome, Neha. Oh my God, it's working. Is the audio working?
Hello. Can you hear me, Kansha?
Yeah, we can hear you. This is
Awesome.
good.
Cool.
Cool. Look, I won't take up too much of your
Thank you.
time. I'll just do a very quick intro. I think we already did, but Neha is here as a senior machine learning engineer at AGL, and she'll be talking to us about all MLOps stuff that they do in practice at a big actual company and stuff. So how does it all work in the right environment? I will leave you go, take over the stream, and enjoy your session.
Thank you. Thank you so much, Akansha. So, hello everyone. As Akansha introduced, I'm Neha Jindal. I'm Senior Machine Learning Engineer in Data and Analytics Center of Excellence in AGL Energy. And today I will be discussing about MLOps in practice at AGL. Um, Before I talk about MLOps, I would like to discuss like how hard it could be to deploy machine learning solutions from dev environment to production environment. And this is the paper from McKinsey Global Institute that demonstrate the same fact. They analyzed 160 global AI use cases and reported that only 12% of the use cases were able to make into production successfully, and 88% of the use cases were not able to go beyond experimental stage, which is surprising to see such low success rate when we are talking about machine learning solution go into production. However, on the right hand side, we can see that for successful AI adopters, profit margin is 3 to 15% higher as compared to industry average. So in short, this paper focused on the fact that however machine learning solution deployment is hard and challenging but critical for business success. Um, just a bit of warning that when I'm talking about productionization and deploying of machine learning solutions, I'm not talking about 5-minute deployment. I'm talking about enterprise grade solutions. There are papers on internet who talk about and teach you how to deploy a machine learning model to the cloud in less than 5 minutes. And that could be possible, but again, it depends upon your definition of productionization. If you are taking deploying models as an API in production as deployment or productionization, then probably it is fine to do it in less than 5 minutes. But when I'm talking about enterprise grade solutions, I'm talking about to make sure all the best principles are there, such as model monitoring is there, auditing, upstream and downstream application integration is there, model deployment, activation, and global governance and security and KPI validation, which are really, really important to regard that solution as enterprise grade solution is there, and every use case has that kind of capability. So clearly, 5-minute deployment is not equal to enterprise grade solution. This slides talk about there is a difference between desktop data science and enterprise solutions, and there is a gap in these two worlds, and enterprise machine learning can help us bridge this gap. Before I talk about enterprise machine learning, I would like to talk about what I mean by desktop data science and what I mean by enterprise solutions. Often when an organization starts working on data science stuff, developing models, they start with people who are in the business already, and they know the business context really well, and they start working on the local data, and the accountability lies within the business only. They are really efficient at small scale, but because there are fewer safety rails, they are not good for the business critical solutions. They follow the project approach, and by project approach I mean is like once the models are built and they are trained, they are considered as done, but and very few or no effort is made afterwards to retrain those models or to evolve those models. Also because those people are sitting in the business already, so the cost of developing and training those models is always invisible. However, on the right hand side, when we talk about enterprise solutions, we are talking about where models and data is centrally monitored and managed. They are governed and secured as any other asset in the organization. They are really efficient at large scale, and there are many safety rails which make them good for business critical solutions. They follow the product approach. And again, like when I talk about project approach and product approach is where the models are treated as managed products, and they keep on evolving to keep on delivering the business value that is expected at the start of the use case. And because everything is centrally monitored and managed, so the cost to develop those models, train those models, and to run those models is highly visible to the business. As you can see, like, these are two different words and there is a gap between both of them. And enterprise machine learning has the challenge to fill this cultural and technical gap, because we want to get best of both of the worlds. From the desktop data science, we want to get business context and the statistical modeling, and from the enterprise solutions, we want to make sure that our solutions are governed and secured and automation is there and the best principles are there, so that we can regard them as enterprise IT solution. So in AGL, we know there are challenges, there is gap that need to be filled, and that's why we developed this platform that we call ML at scale. And another question is why we call it ML at scale, because when I'm talking about models need to be deployed into production, I'm not talking about 5, 10, or 100 of models that need to be deployed, but I'm talking about thousands of models that need to be deployed in production with their own life cycle. We have use cases in AGL, such as site level forecast, where we are training one model per household to anticipate the energy consumption. And as you can see, one model per household, that is like huge. And at the moment, we have 4,500 models that got deployed into production with their own life cycle, and they are getting retrained every day, and they are getting inferenced every 5 minutes. This is the kind of scalability that I'm talking about here. That is why we name it as ML at scale platform. And we built this platform in partnership with Microsoft, and this platform is built top of Microsoft Azure. These are the key products and services, and this is the architecture of our platform, but I will skip it, keeping in mind we don't have much time. So in this platform, we have all the capabilities that are important to have MLOps principles embedded in the use cases, and they are model lifecycle management to manage the lifecycle of the model and data versioning. Because we are working with the real world data and we want to version both data and models for auditing purposes, so this platform enables us with model and data versioning both. Model transparency and explainability is really important, because output produced by those models will be used in business critical decisions, and that is why models need to be transparent and their behavior need to be explainable. Model governance and security is required, because models should be treated as an asset, as any other asset in the organization, and that is why access control should be there, governance and security is mandatory. Data monitoring and data drift is another part, another MLOps principle that need to make sure, like, if there are any changes in the underlying data that could be due to weather change, that could be pandemic, that could be anything that can change the underlying patterns of the data, then data drift is there to make sure that if there is something changed in the data, then alert will be raised and proper action will be taken before they become incidents. So data monitoring is important. Model monitoring and management, because models can drift as well as data can drift. So we need to make sure models keep on evolving and they are always current to meet the business requirements. So these all are the MLOps principles that are really important to bridge that gap that I talked about between data science and enterprise solutions. And ML at scale platform enable us practice these all principles and embed those principles and practices in our use cases to make sure when we move from build stage to the production stage, we do it properly and successfully. Key takeaways. Enterprise machine learning is hard, and they are not just like technical challenges that are involved, but cultural challenges as well. MLOps principle that I talked about briefly are the answers to fill those functionality gap between data science and enterprise IT. And ML engineers are the person who can help you building and running end-to-end solutions. Model obsolescence start from day one. Yes, from the very first day when we deploy the models into production, model can get obsolete, and it can be avoided through data drift and model retraining. We need to shift our thinking from project approach to product approach, because as I said, model needs to be treated as managed products as any other asset in the organization, and they need to be evolved so that they keep on delivering the business value for the longer run. Getting the business sign off on overall return on investment is really important, and tracking this value is essential as well, because production requires further investment and there is ongoing cost of ownership. There is not only cost to build those models and train those models, but keeping those models current and keep those models running also have some cost that we need to take care of when we are getting the sign off from the business. That's it from my side. Thank you so much for listening. And these are my contact details if you have any other question or you want to contact me later on. Thank you.
That was absolutely great. We've got 3 minutes, which again, amazing that you're sticking to the time. I love it. We do have a question that's come through in the chat if you want to take it. So the question essentially is just around how do you find using Azure ML in larger teams? What's the experience been like for you?
I think we are working we are working on Azure machine learning, and we have a team of 20 people, including data scientists and machine learning, and we have built a dev environment, pre-prod and prod environment, all on Azure machine learning space. And I think till now our experience is great, and also like if we have any issues, we have Microsoft people where we can reach to them, and then they can help us clearing those blockers. So I will say it was great.
Perfect. Look, feel free to jump into the chat if you have a bit of time, and I'm sure there'll be people who have a few more questions. But thank you so much. That was a really, really cool presentation. I really enjoyed the whole AutoML things. I absolutely love the low-code stuff. So it was really interesting to hear. Thank you for your time.
Thank you, Akansha, and thank you everyone for listening. Thank you.